I'm the co-head of Spring Studio, and I want to introduce, where have they gone? Greg Morantz, who is the head of UX for Spring Studio, and Jonah Burlingame, who is lead design strategist with us. They're going to be talking with you tonight about how to level up your products with artfully intelligent design. So with no further ado, I will turn it over to Jonah and Greg.
So it's nearly impossible today to read an article about artificial intelligence without it mentioning the disruption that it's going to make on the nature of work and jobs. As designers, it's critical that we are aware of this massive shift that is the relationship between humans and technology. To illustrate a bit of that shift, we have moved from a time when we have had, we worked as kind of part of the machine, if not for the machine, if you will, on the assembly lines, to a time where we worked with machines, to a very near future where we work with machines all around us or alongside us. Artificial intelligence has the capacity to assist humans in their everyday tasks. Think like Amazon Echo, for example. It also has the ability to augment our capabilities, such as a doctor and helping them diagnose rare forms of diseases, all the way through automation, total automation, where we're talking about self-driving cars and eventually robots. Let's take a little bit of time to consider some of the trends and signals that we are watching that are indicators and drivers of this massive shift between the relationship of humans and technology.
Great. So we can't talk about machine learning or artificial intelligence without first talking about data and data maturity and data ubiquity. So as all machines and all data intelligence, data is really the foundations of all of it. And it began with the introduction of personal computing, when we began to digitize our analog world. Everything we did was on paper, so we began to digitize it so that we could take that information so that we could better search it. With the introduction of the smartphones and tablets, we began to become digital natives. As digital natives, everything that we did began to be digital. The way that we communicated, the way that we transact, the way that we consume information was all digital. And all of that left behind a massive amount of data. And now, we're shifting even more with the Internet of Things. So more and more of our devices are getting connected, from the smart home to wearables, all of which leaving another trail of data behind that we can now begin to consume to make better experiences. And it's not just data that's improving. Computer power is changing. So I don't know if people here have heard about Google and IBM are set to release by the end of the year very powerful qubit quantum computers. And for people that aren't familiar with quantum computing, what it really is it can take data, even the ones and zeros that normal computers do, and it can break it down into subatomic particles. What that really means in layman's terms is it can process information at literally hundreds of millions of times faster than the fastest machines that we have today. And this is set to come out within a matter of weeks. Now again, it will be piloted, but once that does come out, it's going to be a massive game shifter. I mean, we're talking on the level of the microchip as far as the amount of information that can be processed that can break down and improve and make improvements on artificial intelligence, health, looking at cells, atoms, and genomes. And while most of us will probably not have one of these machines in our home, we will be affected by it. But it's also not just computing at the core. Computing at the edge or computing in our devices are also shifting. So up until recently, when we looked at artificial intelligence and we used that on our machines, it was happening from the cloud. But with the latest release of the newest smartphones, we're now seeing that artificial intelligence is actually put in the devices themselves, which has given us the capability of having instantaneous facial recognition, instantaneous access to augmented reality, as well as looking at the Google Buds in the example, it can translate up to 40 languages in real time as we speak. So all of that power is changing the way that we work. And it's not just, so we have a ton of data and we have massive computing power, but we also have, all of that leads to machine intelligence. And one of the signals that we're seeing in machine intelligence that's really exciting to us are these algorithm marketplaces. And the reason why they're exciting to us and why they're such a game changer is when you think about, let's even take building a house. When we first started building houses, we had to find the right trees. We had to cut those trees down. We had to find all the materials and build that, which took a long time, was very limited, and limited to what we could do. But once we began to componentize that and modularize that, we could then take all the different pieces and build massive, great houses. Well, the same thing's happening in AI. As these APIs become more available that give us these algorithms, we can then mix and match these different algorithms to create newer and smarter experiences. And another signal that we see that seems to be that will be very transformative to the way that we work is generative design. So in this example, there are now tools where we can enter in criteria and have machines help us with the design process. So imagine we went into a machine and we wanted to build a bicycle. And we knew that we wanted that bicycle to weigh less than 3 pounds. We wanted it to cost about $70 to manufacture. We wanted it to be completely aerodynamic and to be able to support somebody that could weigh 250 pounds. Traditionally, what we would do is we'd begin to prototype. We'd take all different types of materials. We'd start to design it. And what we'd end up getting is something that looks a lot like a bicycle that we use today. With these types of tools, you can actually enter in those criteria, and it will produce hundreds, if not thousands, of results, changing the way that we process that information we designed so that our role becomes more as a curator versus necessarily as a designer. So I think the big question that we often hear when we think about this type of technology is, what is our role as a designer going to be, and how does that affect the way that we do product design? There are cynics that believe that AI will disrupt that. I'm not one of those cynics. I actually believe that AI will unlock a lot of things for us by taking on these types of tasks and creating new materials. We can actually think about bigger problems and be able to solve bigger issues and think more about the strategy behind them, as well as begin to produce things that we couldn't do without some of these machines and that the machines couldn't do without us.
So a great deal of what we're going to talk about tonight is the result of our strong collaboration with the data science team at BBVA. We've been working with them for a couple years now, and we saw when we brought data science and design together that we were able to create much more intelligent experiences. And what we're sharing with you tonight is a bit of our learnings from that journey of working with the data science team. And it primarily comes from a designer's point of view, so hopefully it's useful to you. We will start with kind of a basic understanding of machine learning, a practical understanding, if you will, and really kind of level set the room to make sure we're all speaking the same language, and talking about machine learning and artificial intelligence and what's the difference, or they're the same, and so forth. In its broadest definition and simplest definition, artificial intelligence is really just any showing of intelligence made by a computer or robot. It's what constitutes artificial intelligence is often disputed, and it's called the AI effect. Some say that AI is whatever has not yet been done. So it's a bit of a moving target when you start to describe artificial intelligence. So let me explain. In the 50s, a bunch of scientists came together and they put a bunch of rules in a computer of all the possible chess moves possible. And at that point, you could play against the computer. But the computer never got smarter, right? So by that definition, this AI effect, we wouldn't really consider this artificial intelligence anymore. However, just recently with AlphaGo, you may have heard this in the news not too long ago, some ex-Google employees recreated one of the oldest games in history called AlphaGo, and within a matter of about 17 hours, without giving it any rules, it watched top players play the game. It learned how to play. And it subsequently beat the top player 5 out of 5 matches. Pretty astounding, in about 17 hours. Add to this something else interesting, in that one of some of the first moves that the computer made on the game, the players, the opponents, thought this was a mistake because it was a very unusual play that they made. Turns out that unusual play was the key to winning the match. So it taught these top players how to play the game. So astounding. So this is a really good illustration of what a game changer machine learning is. But we have lots of examples of intelligence around us today, and it's kind of a spectrum here. Everything from your basic Google search, in which it has predictive capabilities, knowing what you're typing and what you might be looking for. That's always learning to give you the best answers. Spam detection, those spammers are pretty creative. They're always coming up with new patterns. It's constantly learning what constitutes spam and trying to help you out. GPS navigation, weather forecasting, complex things like supply chain logistics, and then autonomous cars, which are all over the news and everything. So quite a range of what we consider intelligence to be today. So now we've talked about intelligence, specifically artificial intelligence, and we've talked about machine learning, and oftentimes the terms are used synonymously. But there's a subtle difference, and this will probably make you buzzword compliant, and you can talk confidently at cocktail parties. But artificial intelligence could be considered more of an umbrella term for a lot of different subfields, such as machine learning, speech recognition, and so on. Tonight we're going to cover machine learning because it's what we have been working on with the data science team here a little bit more, so we're going to narrow the focus a little bit tonight. To understand a bit about machine learning, we have to think about an overly simplified illustration of a complex problem. Taking a bunch of photos and understanding which ones are cats. So in this illustration, we might come up with a set of rules that said it's a cat if it has whiskers and it's furry. But we might get a photo of a lion, which isn't actually satisfying our definition of a cat at this moment. So we put another rule in here to say, and it is small. But then we might get an example such as a koala. So we go back to the algorithm and we put a new rule in there and we say, well, and it doesn't climb trees. Well, as you know, some cats do climb trees, right? So this illustrates the complexity of using rules, handwritten rules, to kind of define these things. Machine learning changes all of that. Here's how. Just to recap, we're putting rules into a machine, applying that to data, correcting the rules, and keep doing that in the traditional method. Very cumbersome, not scalable. What we do with machine learning here is we apply a set of training data. So we take known images of cats and known images of non-cats, and we put it into the machine and have it guess, and then we correct it. And ultimately, it creates its own algorithm. Then we apply that to the larger data set out in the wild, and then allow it to update the algorithm itself. You've heard perhaps sometimes referring to that as a black box, because even the data scientists don't know how the algorithm is created and what it means. It's spaghetti type code that comes out of that. But the machine is creating the rules itself based on what it identifies as a cat.
Great, so now that we have a basic understanding of machine learning, we're going to get into creating intelligent experiences using machine learning. And as always, we're going to start with data. With natural language processing, with machine learning, the way the data is broken down is by two categories: structured data and unstructured data. When we think of structured data, we think of things like closed variables, things like thumbs up, thumbs down, star ratings, emojis, anything that is binary that a machine can read to easily compute that information and create meaning out of it. The problem is that most people don't speak that way. Most people speak in words, they speak in images, and that's unstructured data. So these are things like your Yelp reviews, your Facebook posts, Instagram feeds, etc. All of which traditionally have been very difficult for machines to be able to pull meaning and content out of. All of that's shifting though. So with some of the other tenets of artificial intelligence, like natural language understanding, there are now engines that can pull data out of text and pull meaning and content from it. With computer vision, they can go into not only images, but videos and pull out who are the people in those videos, what's the context of what's going on, what emotions are there, what are all the things that are happening in there, and pull out that information. And we've already talked about speech recognition, where they can pull what people are speaking and actually pull data from there. One great example is what Facebook is doing. So on Facebook, if you were to ask for a recommendation, it recognizes that post as something different from the way another post would work. So in this example, Mona is asking for a recommendation for a hair salon in San Francisco. And all the responses that have come back, Facebook is taking all of the data that's in there and it's looking at all the different words and it's trying to map any of those to a database of, are there hair salons in San Francisco that map to that? And when it does find that, it's actually surfacing the results with the ratings, the times that they're open, links to them, and even the address for how to get there. So, as designers, our users and who we design for is changing. It's not just designing for the end user, which is what we've always done. We also need to design for the machine, and so that the machine can learn about our end user. In this example, we're going to take a user who's listening to a streaming radio service, whether it's a Spotify or a Pandora. The user chooses to listen to a song. They give it a thumbs up that they like that song. The machine goes, oh, you like that music, you like that song, we're going to take note of that, and we're going to recommend a similar song. Listen to that song and get all the way through it. Machine says, great, we're going to recommend yet another song. But this time you do a dislike, and you say, thumbs down, I don't like this. The machine again is going to take note and say, oh, you don't like this song, let me recommend something different. You skip that next song, and it recommends a different song, and it just goes back and forth. And that's called a feedback loop. These are mechanisms where we can collect explicit information, like liking the song or disliking songs, and implicit information, like whether you got all the way through it and whether you skipped that, and begin to keep training the data so that it gets better and better with the recommendations. A great example of explicit versus implicit feedback is Netflix. So Netflix learned early on that people like to review information, they like to be able to control the recommendations they get. So when you look up a movie, there's now thumbs up and thumbs down for that. It's really helpful information because it tells Netflix whether you've seen something or not, but it's actually not really used much in the recommendations. And the reason why is because even though no one else is seeing that information, people have a different image of themselves, and they tended to review things that were more highbrow, like documentaries, art films, classic films, much higher than comedies and drama. And what they really were watching were the latest Adam Sandler movies, or Roadhouse for the 45th time. So as we begin to think about how to design our products, we also need to think about what are the types of feedback we want to get. Are there instances where we'd want to collect explicit feedback and get feedback from users? Are there instances where we can collect implicit information, and how do we design those into feedback loops? Both of those examples are great when you have a data set to work with, but how do we train a machine when there isn't a data set? This is, again, another ex-Google employee tool where they're trying to teach machines and neural networks how to learn what people are drawing through doodling. So knowing that everybody doodles and draws things differently, how can machines really quickly identify that? And we're going to use it real quick to show you how it works.
This is my favorite part, where we get to watch Greg draw in front of 80 people live. So.
I am not a great drawer. All right, so the way it works is it asks you to draw something, and as you're drawing, it's going to continually make guesses as to what you're drawing to see if it can figure it out. And the more people that actually do this, the better the neural network gets and the more information it has. So you're going to watch my drawing skills belt. I luckily got an easy one, I think.
Let's see if the sound works, because
maybe not. See, so as I was drawing, was this any sound coming through?
No. Try it again.
So we'll do one more.
Yeah, do it again.
So as I'm drawing, you can see below, it's trying to figure out what I'm drawing, because I'm not a very good drawer, and then it guesses, and once it hits that match, it does that, and it goes on until, as it's training the machines. And what's really interesting is how it trains the machines. So we can actually get a bird's eye view as to what's happening here. So in this instance, when we're looking at how it learned how to draw birds, there's 111,000 examples here of what people have submitted, and so how it can identify that. And not only do we see those examples, we can actually hover over them to see how people are drawing these and see what the patterns are. And one of the things that we noticed is in a lot of these, the first place that people started was with the head and with the beak. What's interesting there is even before you finish that drawing, these machines can recognize the patterns of how you're drawing to be able to identify it even faster.
This is pretty incredible that Google's exposing this to us so that we can see how the machine is learning and what it's capturing. Fascinating stuff. To me? So with all of this, we have new fundamentals of design that we have to start paying attention to. Just as we did 10 years ago with the invention of the smartphone and so forth. We had to learn how to design for touch interactions, tap, pinch, zoom, and all of these. We have to do a similar thing today with this shift with machine learning and learn how to design with and for algorithms. Now, this doesn't mean that we need to learn how to write algorithms, so to speak, but we should be aware of how they work and which ones that we can start to use, and how to communicate with data scientists to talk about what we want. For example, what we learned early on was there's a huge gap in understanding in the terminology that we were using as designers when we were talking to the data scientists that we were working with for the first time at BBVA. Recommendation came up at one point to where we were saying, well, we want to provide recommendations for a customer to do X, Y, and Z. And the data scientists would scratch their heads and say, that's not a recommendation. I said, what are you talking about? We're recommending that they do something. I said, no. In data science, recommendation, it means a very specific thing. It's about an engine. It's an engine that is a sort order of a list of things. And it's not a piece of advice. So we had to adapt our language a little bit. So just a quick anecdote there about the fact that language and terminology is important in this. So we'll do just a quick example of how to design these intelligent experiences. And we'll do a simple example here. This is the regression engine, also known in design language as a prediction engine. In that here in BBVA's Valora app, and this is an app in Madrid where they help predict the price of a home to help people buy homes. And so they're providing here an approximate purchase price, and it's their best guess of what they think that's going to go for. As a side note, I thought this was a mistake when I looked at it and I said 678 and 644. Why would that number be lower? It's because we live in the Bay Area. I thought it was broken. So let's look behind the scenes a little bit at what goes into this. Naturally, we start with data. So, it's things that the machine's looking at, such as maybe number of bedrooms, bathrooms, square footage, some of the amenities, the last sale price, and comparable sales. Puts that into a regression engine, and we get the estimated price out. But naturally, we have to remember our feedback loops, right? So in this case, we have potentially two feedback loops that we see, and one is user correction of those data points. So it's very important that if those data points are wrong, we allow the owner of that home to be able to correct them. And then also, it's important that we capture the actual sales price in order to feed that back into the regression engine and make sure that it becomes more intelligent over time. Make sense so far? All right, let's go to recommendation engine. Here are recommendations from Amazon. And this is a list of books that they are recommending for me that they think that I would like to purchase. What goes into that? Well, we have things such as maybe my past book purchases, other general purchases, as well as comparison purchases. That's things like they've identified people like me and what they've purchased, right? And we take that data, put it in the recommendation engine, out come the book suggestions, and then we can't forget our feedback loops. We have a multitude of them here. The actual conversion, did I buy a book that they recommended? That, of course, is very good feedback. Did I add it to my wish list? Did I explicitly say I'm not interested? Or did I provide a star rating, which might indicate that I've already read it, right? So very good feedback loops here that kind of keep this smart, and why these recommendations typically are pretty spot on, at least in my experience. It gets really exciting when you start to combine these engines, right? So here's a very small experience. It shows up on your iPhone lock screen. And I don't know if you've seen it, but when I saw it, I thought this was just incredible. I thought it was magic. But it knows, based on my past behavior, it predicts where I'm going to go when I get into my car. So I hop in my car, on the screen comes 7 minutes to get home. So how does it know that I'm going home? well, it knows that I usually go to that destination which I've marked home, and it's that time of the day that I'm ready to leave. So it's predicting that. And then it's also predicting how long it's going to take me to get home, 7 minutes. It's providing a score, so the traffic is normal right now. So there's some sort of scoring going on that's saying this is normal traffic. And then if I were to swipe into that, it would provide me recommendations on the best route home. Right? So a lot goes into an experience that is really just this, the right information at the right time. This is anticipatory design, and pretty exciting.
You imagine as we get more and more data that anticipatory design just gets stronger and stronger. But when we think about how we get data from our customers, we really need to think about how do we get consent from them? And part of the way that we gain consent for getting information is by being trustworthy. So here's an example of a big bank. This is something we just made up. But imagine logging into your bank and they're asking for information and access to your social feed. Now, as a designer who works for a bank, I can tell you that information would be invaluable, not only for the bank so that they can make better recommendations, but it could actually make a much better user experience. The problem is, most users don't know that, so it's not relevant to them. They don't know that by giving that information, they might get something different, or they don't perceive the value in it. So to ask for it, they begin to question your motives, and they begin to question the trust that they have for you. And like in a regular relationship, once you erode that trust, it's very hard to get that back. So while there might be tons of valuable information you need to be very careful when you ask for it and make sure that users have a perceived value as to why they would give you that information. Also integrity. So how are you coming up with these recommendations or these numbers? Here again, looking at another real estate site, we can look at Zillow. They have, similar to what we saw in Valora, a Zestimate, which is telling you what they believe a house price will actually go for. This is a really important number. This is a number that people look to understand what they should bid on a home, and it could make the difference of them winning or not winning a home. So what's great about what they're doing here is you can actually click on that, and if you were, let's say, the homeowner, and this number is based off of certain data, you can modify that. But you can also see how they came up with that number and what the confidence is of that number. So we can see here in Baltimore, they have a really high confidence that that number is going to be pretty accurate versus in Cleveland, Ohio. And we can also see what that confidence is based off of. So in here, it's based off of how many predictions did they make and how close to the predictions were the actual sales there. So again, showing that integrity and showing that you're going to tell people how it works also helps build that trust to enable them to give you more information. There's also transparency. What are you doing with people's data? How are you using it? What information do you have on them? Google's kind of changed that whole privacy policy from being this long legalese to being something that you can dive into that not only tells you how they use your data, but you can actually see what data they have on you and you can clean it up. Speaking of cleaning up data, going back to Amazon. So with the recommendations, those are all based off of what you previously purchased or what you previously browsed for. But sometimes maybe you purchased an anomaly. Maybe you bought a baby present for a baby shower, and now you're getting all these recommendations for baby things, and that's not relevant to you. What Amazon lets you do is actually go into your browsing history, and you can choose to remove things called
Profile detox is what we call it.
So you can do profile detox to be able to remove things so they don't show up in your feed, as well as be able to tag things that you really want to show up more with a more like this function.
So we've talked quite a bit about how machine learning is going to impact the design for the machine and for the design for the users. But what about how it's going to impact the designer and our roles and our discipline, right? It's going to bring on new channels, so new skills. It's no secret that we are not converging on the number of channels that people are interacting with. We're actually diverging, and we have a lot more than ever. We have very interesting new interfaces by Amazon alone. We have voice and screen, voice only, voice and text, just a whole multitude of ways of interacting with our devices. And so there are new skills that we have to develop, like conversational UX, which is a term you probably start seeing a lot more. And it involves quite a variety of skills itself. Everything from things similar to information architecture in structuring the language and intents and utterances and how you resolve those things in a complex way, all the way to tone of voice and brand, and also the channel strategy. And if you have an intelligence platform that is serving all of these different channels, you may not surface the intelligence in the same way on those individual channels. So putting that recommendation out in text may look very different than when you do just voice. It's not a one-for-one. So there are a lot of considerations that we have to make with these new channels.
And it gets even more challenging when you think about a Google Home or an Alexa that doesn't have a screen, and they're communicating with their voice, your product, and you still need to be able to convey your brand, your voice, and your tone. So that is in how you're writing the responses, how you actually teach the machines to learn to speak, and to speak the vernacular and local nuances of people that it's speaking to.
Along with and impacting our design tools are new tools like this, Personality Insights, which creates automatic personas. This is done by IBM Watson. It's a bit of an experiment at the moment, so it's not ready for prime time. But it's interesting. I think it's kind of a signal of things to come. As designers, we really like personas and crafting them with care, but with all of this data and being able to shape it in real time and giving us an accurate reflection of different persona types, this could be a game changer for us. In this particular example, you give it access to your Twitter feed, and it goes through, looks at your tweets and your retweets and things you like, and it matches your personality with other people. So, bizarrely enough, I'm very similar to Kanye West and Bill Gates. I don't know how that's possible, but. Another new tool, which we kind of gave a little bit of a sneak preview early on in the talk here, is this one by Autodesk, which is called Dreamcatcher. And we're going to play a quick video for you of it, but it's the generative design. This is a tool that they have that spits out hundreds, if not 1,000, different solutions based on the criteria you define. So let's play this. Oh, is it, am I going to get
Turn the volume up on the machine.
I did. Is it unplugged? I don't know what happened to it. It worked in rehearsal. Sorry about that. I'll do the voiceover. So here they're talking about putting in the criteria that is for a drone carriage and being able to carry a certain amount of weight and so forth. It presents the designer with just a ton of different options, and it was up for the designer to curate and to decide which one thought was going to be more visually appealing and solve the problem better. So it really, and you can apply this obviously to anything that you can design structurally, and you can see the different types of forms that it comes up with, including, they'll show an aircraft here, where they were able to give it the criteria to design structures like walls within the plane. Here you go. And it was able to create something that was, I think, 40% lighter and just as strong, if not stronger, and it was able to save fuel for every flight. So there are real applications for this. It's worth watching the video. We'll have a link to it. We'll send out to you afterwards. Okay. All right, and so we're going to share one last tool with you, and this one's a little bit homegrown. Admittedly, not as sexy as the other ones you just saw. This one's decidedly analog. This is a piece of paper that we use here, but it's something we wanted to give to you so that you can go back to your jobs and start using and start thinking about artificial intelligence and the opportunities, the capabilities, and start applying this stuff today. So we have some printed out on the table here you can take with you, and we're going to follow up in an email. It'll have a download of the PDF and so forth. But in essence, it's the AI canvas is modeled after the business model canvas, if you're familiar with that. A series of boxes that really facilitate a conversation of talking about a product that you can then provoke questions to see, are there opportunities with the different AI technologies that you might be able to solve? So we tried to cover things both above the glass, things that face the user, as well as below the glass. So things that are back-end processes, for example. Are there opportunities for optimization and automation, capturing some business intelligence, insight and foresight for the user, as well as talking about the various channels and capturing data sources and inputs. So this is something we've just begun to use, and we want this whole evening to be about dialogue. We don't know everything. We're just as curious as you are. So we encourage you to ask questions, to give us feedback on the AI Canvas and this talk, and start the conversation in this community. And that's what this meetup is all about. So thank you very much.